More recently, this year, I published this book, Web App Front-End Development Best Practices. It's actually very, very thin, but it's still loaded with stuff. Best practices, as I've been watching the last 7 years, of every 18 months, another framework coming up, being the hottest thing, the bee's knees. Trying to create an approach that that helps get through that and create apps that are future safe, maintainable, and stuff. This is also me recently coming out of CNBC because they wanted to hear about this stuff. That was just a day, but I keep flaunting it because, you know, it's a good name. So talking about web frameworks, and I count standard web components as a framework, we always have to think of the goal, which is to create maintainable, future-safe apps faster, efficiently. Sometimes we lose track of that, and we just adopt the technology because it's good for the resume or because the boss said so. But really, the ultimate goal should be to be able to create apps productively, efficiently, and we don't want to have to rewrite them every 18 months. So this presentation is structured in 3: foundation, bricks and mortar, and the perspective. So what we're going to talk about, totally forgot, I need a timekeeper. The role of the timekeeper is to raise his hand every 5 minutes. You will do that? Thank you. Starting now, so I can pace myself. So we're going to thank you. We're going to talk about standard web components, including HTML templates, HTML imports, custom elements, shadow DOM, lifecycle, loading, app shell, business logic, styling, Polymer, and SSR, server-side rendering. So with that goal, the foundation is to understand what are standard web components. Oh, attention, forgot to mention. Wait, here, forgot to mention. Everything that you're going to see here that is supposed to be HTML is not going to be HTML. It's going to be Pug. Who knows Pug? Who? Yep, written one, forever 5. Okay, for those of you who don't, this is not a framework, but it's the greatest invention since sliced bread because it's a different way of annotating HTML. On the left side, you see HTML proper. On the right side is the Pug version of it. So you see that they did away with all the brackets, and they use the indentation to reflect the structure of the HTML. And then you have a preprocessor or a processor. So what you would do, you would write your HTML like on the right side, and your Node.js, for example, is wired to translate it into HTML, what's on the left side. And once you spent half a day learning to write Pug and have it set up so it generates this to send to the browser, you'll never want to write any more of those stupid brackets ever again. We use it everywhere we can, which is almost everywhere. What you're going to see on other slides here is going to be Pug. So you'll have to think that when something comes up and it's indented, it's just one level below inside. You see that. What else should I point out? Well, body tag over there on the right side. You see body h1, and then you see this hash container.call. That's interesting. That the same sign that you use in CSS to indicate an ID represents the ID of a div here. And then any class that you want to add to this div, you append with .call. Or if you have a div that doesn't have an ID, it would just be .call, for example. And that's all the magic there is. That's all you need to learn Pug, pretty much. Yeah, go ahead. Question. Oh yeah, you can. You see here in the script, pretty much here at the top, to do an attribute, you put that in round brackets behind the script tag. So type equals tag/JavaScript, which is actually in HTML5 superfluous. That should not be there. But it's a good example of showing attributes for tags. So that was just the attention. That has nothing to do with the web components, but to get you ready of what you're going to see. All right, web components must be like Legos. Everyone knows Legos. Composable, reusable, and modular. In addition, they must be able to communicate. This is a Kickstarter project. They actually made it out of it, and they're now in production. Building blocks with electricity. You stick them together, and they communicate. That's an added complication. There's been many years spent trying to come up with a good concept, a good solution for web components. And every 18 months, there is another, there's been another attempt at another framework and stuff. Why would we want web components? Why would we want to componentize? Well, I see two main reasons. The first one is they help you hide the ugly stuff. You want to encapsulate it, hide it away, so when you touch it, when you use it, you don't have to see all that crazy code that goes on behind the scenes. And they're supposed to be good for reuse. You're supposed to be able to reuse a component, plug it in somewhere else, use it in a different app on a different screen in the same app. And that's an example here, and I want you to see that running. Standard web component, typical dashboard, where you click on one item. In this case, it's a list in the middle. Then the stuff on the left, on the right changes. So I'm going to just see if my network connectivity here or my bandwidth allows me to actually do that. Let's see. I've got a project running here. Okay, so this is an actual standard web component. You see on the dashboard. Once we navigate to it, you click on one, and then it changes the values on the others. So they need to be able to communicate. Obviously, this one in the middle here normally would be a drop-down or something. Select something, and then the others would be showing whatever values for that topic or for that item. We have the sample project, and the URLs will come clear where to find that. This is one of the tutorials in this book here. This book is also available online, a preview for free, and there's a website with corresponding to the tutorial GitHub projects where you can pull all that up and look at the actual code, or more of the code than we'll just see in this thing here today. How will you join audio? Can I just get rid of that? I don't know. No, I can't. There's an X in the... Yeah, I don't want to do that. All right, well, there's nothing behind... There we go. All right, now this is a screen that's purposefully not showing you the details. But the site exists, Hyperpolyglots, GitHub.io, so much fcarp, made a comparison of React, Angular 2, Angular 1, Ember, Polymer, and Vue, how they do different things. And the point of this slide is they all do them slightly differently, but from a 10,000-foot view, they don't do it that much differently. They're really, they really should not be different religions. They kind of all believe in the same God, in my opinion. So the question is, which one do you choose to get to heaven? And the answer is, well, no, you don't know. Probably neither of them, maybe all of them. But it's hard to guess. And in fact, what gets you to heaven changes every 2 years, right? So what do you do with that? Well, you have to design for change to be future safe. And big question, how can you design for change? Well, we'll cover some of that, how to design for change. So looking at the history of things, one thing, I took this example directly from the React homepage. How does a React component look like? It's basically JavaScript with a renderer where you have the HTML inside the render, or you pull it from somewhere. Standard web components are, personally, I don't think that's very maintainable, but a lot of people disagree with me. A lot of people. I also think it's not very designer friendly, but a lot of people disagree with me there too, but most of them are not actual designers. So what standard web components do, they're DOM-centric. Now, where's the HTML? Again, this is Pug, all right? Imagine here, this is a tag with the name template and an ID of xgauge-l. And so inside that template, and that's something new that was agreed to in the web component standard, is you can have a style, basic CSS. Here, this is a div with a class, or a gold span. So here, this is HTML, and in this case, you have a div with an ID named gauge1, and you can have some script. And in this, so this is all file. This is actually a standard web component, or a Pug representation of a standard web component. Probably it would be named .html. It has a template and it has some script. Now the script has some instructions how this whole thing should be built, set up, and how it's going to work. So in this case, we're using object create from a prototype HTML element, and so this variable represents a prototype of this component. And then we keep around an instance of that component too. We'll look more. And then inside of that component, you can have all sorts of custom stuff. For example, here we're using a library, justgauge.com, which does the fancy, beautiful thing of that gauge that you saw on that screener that went like this and this. Someone wrote that, and we just packaged that into a web component, standard web component. So you can see that this is DOM-centric. Where's my timekeeper? 5 minutes are over. So well, we see that this is DOM-centric. It's really declarative for the most part. It has HTML, and then it has some script. And the script could be a little bit further inside too. Yeah, go ahead.
Would you use this DOM-centric web component here in combination with something that's also, I would think, DOM-centric like Vue.js?
I could, and we'll get to how I'd wire it together. Okay. So obviously, we're not the only ones that have seen all these things come and go, all these frameworks come, and some become less popular already. So a lot of smart people sat together and said, well, we need to create a standard. And good place for web standards is W3C. And so they created these sub-projects, in a way, that are the 4 main topics for standard web components: shadow DOM, custom elements, HTML imports, and HTML templates. We're already seeing the use of this template tag. Basically, that's what under HTML templates. What I'm showing you here is the GitHub project for the standard web components from the W3C, and what they've done, how far they have matured. Most of the parts are now maintained in the DOM standard. Spec is now maintained in HTML standard. HTML templates are upstream to HTML standard. So people worked on this for years, 4 or 5 years, maybe more, until it was so mature to say, well, hey, now let's make it real. After we figured out how we want it to work and what it's supposed to do, let's move it into the actual DOM standard and HTML standard. Now, that is really a good thing because that means browser vendors can actually base themselves on something when they put the stuff and build it into their browsers. Now, there's one browser vendor that has a leg up on this one, and that happens to be Chrome, Google Chrome, because the people that work at Google were instrumental in defining these standards or spearheading these standards. So all these 4 things are in current versions of Chrome are supported. Now, what that means is that it's a web framework, a component framework, where the browser doesn't actually have to load anything because it's already there. Or when you have Safari, Firefox, these pieces, they don't have to load them anywhere, they're already built in, which is great. Every time you do a run React, you have to do 200 kilobytes or whatever it is of loading of stuff to make your app work. In Chrome, you don't have to use these standard web components and so on. For all the other things that are here, polyfills exist. Pieces of JavaScript that you load that emulate the functionality. They're not necessarily perfect, but they kind of make it work in other browsers as well. Maybe just a little slower, but at least it can be made to work across those browsers, which is a good thing. So there are really 4 pieces of this. The first one, HTML templates, you use that to declare the content and the style. We've already seen this one. Yeah, template at the top, HTML, style, bottom, script. The second part is HTML imports for loading and late loading. Now you have to get these web components somehow onto your page, into your app. And HTML imports is one way to do that. There's other ways, but essentially what HTML import looks like is this. Again, Pug, imagine this to be the beautiful HTML with the brackets and things. Where in the head tag, where you typically load your JavaScript and stuff, now you can create a link tag with a rel of import and the href. So a human being has a heart, so a heart is a component of the human being. Here, this brings the web component heart.html into the app, into the page. Into the page DOM, actually. There's more detail to it, but globally now, that's not the only way to wire a web component. Obviously, what you just saw on that screen can also be done in JavaScript. This is an example of a JavaScript that loads that, where you create, through JavaScript, create a link element. You set its href property, its rel property, and then you append it to the head tag. Same thing that you see, just written in JavaScript. There's other ways to add through JavaScript, because all that really matters is that this component becomes part of DOM somehow, of the whole page, of the whole document. So you can load it into the head tag through this, but you could load it into the body, to the end of the body, to the beginning of the body. And you could use an AJAX request, a fetch request to get it, and parse the response. So you don't have to use this construct here of the href. But it's one way of doing it. Polymer as a framework, invented by the Google guys on top of those web component standards, uses these HTML imports a lot. They're declarative. You look at the web component at the top of the web component. If you have a web component in a component and a component in a component, you can have Russian dolls where one loads the next and the next needs these others and so on and so on. So personally, I'm not in favor of embedded components, because at the end it might take you 8 seconds to figure out what the whole thing looks like. There are ways around that. One of them, of course, is write smart and try to keep these things as flat as possible. It's also a little harder to test when someone on the 4th level wrote something or modified something. So it's the nightmare of Legos where you build a castle with Legos, but Legos are static. Now imagine someone changes the consistency of the piece of Lego right in the middle of the castle, middle of the process because he wants to and forgets to give it to QA first. Suddenly you have a castle with pieces that are melting. So that's problematic. So third piece is we'll talk about custom elements. Custom elements is an API which helps define, well, it can be used to create a web component in the JavaScript. Earlier you saw where I said object create dot something something prototype. This is the custom element API uses the concept of class, which is not available in all browsers, especially our good old friend Internet Explorer doesn't like class. So there's two ways to deal with that. Of course, one way is to take this and down compile it into ES5 and use the down compiled version of that. The other alternative is to just write it the way that older browsers understand too. We have chosen to, until IE is fully gone, still at 3% of usage somewhere, we're still going to use the old style. We're not going to use that because what this custom element API does, in most cases, is not very much. It just creates, extends HTML element. I had another way of writing that, so I used the other way. Our functions look a little prettier in a class, but everyone who knows JavaScript very, very well knows that class was just invented for Java programmers to make them feel happy about JavaScript. So I object to be fooled here and have decided for now not use that custom element API. I don't have to. Now, unfortunately, me, if my code works using ES5 object prototype, why not? So that's what we do. You've already seen that. Agile object create does the same thing. And then the functions look a little bit different. The prototype functions defined here, they look a little bit different, but so what? Still understandable with a modicum of understanding of JavaScript. So I say don't use them yet. I hate down compiling. If I can't see my code immediately running, I get upset. So if I can avoid any kind of sausage making factory in between my code and until I can see what it does, where I potentially have to debug, I'd like to avoid it. Fourth one, use Shadow DOM to avoid CSS bleeding. One of the good old problems of component frameworks is that one component style sheet could bleed into the rest of the application and vice versa. And our great standards people decided to add the concept of Shadow DOM. Of course, they didn't invent it. There's other frameworks that have used and are using Shadow DOM. But they decided that was a good idea. Let's put that into the standard. And so if we don't have to, but we can create a component that uses Shadow DOM. So down here, last line, very bottom, you see TW attach shadow. TW is a little helpful library that we wrote because to actually attach a shadow or turn something into something behind that firewall, turn that into the shadow is actually 3 or 4 lines of code. I'll show that on the next slide. But in essence, what happens here, what we're saying is, let's take the content of the template with the ID xgauge, X for, well, hidden, right? Shadow. Take that off here and put that as a shadow to this thing. And what's happening in that process, so that it becomes isolated. And then, of course, the browser knows what a shadow DOM is and makes sure that nothing bleeds into it. So attach shadow, this is the actual implementation of what you just saw. That's what I'm getting the template. I'm creating a clone, and then I'm creating a shadow, and then I'm attaching the clone to, appending the clone to that shadow thing, and suddenly it's gone from the bleeding, the bleeding has stopped. Great. I'll move on because obviously there's tons of stuff that happens behind the scenes after this. We're already in step 2, the bricks and mortar. Now it gets interesting how we wire this stuff together. Because so far you've only seen the concepts, the basic building blocks, if you like, for standard web components. So components have a life cycle, and we're going to talk about these now. So to be able to use a component, well, you have to put the component in the page HTML. For example, GaugeL, this component that we've been talking about, my dashboard has it. There's another screen that has it by itself. It has a tag named GaugeL. -L, every component has to have a dash in it. They agreed to do that to make them differentiate from primary HTML elements. Then, and we saw how we did the import, but alternatively we can do a fetch as the new API, replacing the old HTTP AJAX request stuff, and add it to the DOM with an append child somewhere. What you also have to do, tell the browser that, hey, this is actually a component, because the GaugeL, until we get down here, the browser doesn't know what to do with it. And it doesn't do anything with it. So as it's rendering the page, and if it hasn't been instructed, it will just go over it. If we can instruct the browser later, tell them what it is, and then it will upgrade that element to what it's really supposed to look like with all the content according to the instructions. But to be able to do that, the component has to be registered, and there's a call to document register element with some parameters that does that. You're only supposed to do that once. The standard just says you have to do it, but oftentimes in actual life, people try to call it several times. So unless you use a framework like Polymer, you have to build a little map list somewhere of stuff that you've already registered so you don't register it twice. But that's 5 lines of code. Order of magnitude speaking. So you have to make that call to tell it that has to be registered. And then if you want, you attach the shadow DOM in the component created callback, and which triggers the custom, from where on you trigger the custom rendering, the work. Let's see what we got here. Next one is loading into App Shell. I have the feeling that component created callback, I hadn't shown you that. I was kind of going over that a little too fast here. Let's see. Yes. The API for web components has, for custom elements actually, has a number of callbacks that once this thing has been created, attached to the register and attached to the DOM, this callback gets automatically called, which means this is where you can do your processing. One of the things here we did, create the shadow, turn this into a shadow thing. But the other stuff that would happen further down is where you'd say, hey, let me take the value from where it came from, if there is one, or display a default value with that beautiful JavaScript that actually does the gauge thing. That could be triggered from here. Of course, you can also communicate to the component to do it again later or do something else later. But I wanted to show you the create a callback. So this is a standard API. If you're using Chrome, then you don't have to install anything to make that happen. Let me go jump to the lifecycle again. We've been through the lifecycle stuff. Now, in practice, how does that work? Where do you do what? And I'll tell you where we do things. And what we did when I showed you this, this page that was doing, you know, the dashboard. So what we do is, come on. Nope, one more down. Right. The concept of the app shell is taken on the Google website. The idea is that most apps have a menu bar on the top that really hardly changes. That's a shell. And you have other pieces that change the content in this pane. So nothing to do with web components by itself. When we build an app that works like this, then first we load this, and then we load the specific content for that particular page. And then if there's navigation, we don't typically reload this browser, the menu bar. We just swap out the content, which is nice because it makes it feel fast. It makes it feel responsive, more immediate, because it feels like a rich client app, like a mobile app where you really only replace the stuff. What we actually do, again, in parentheses, because not necessarily related to web components, is we have a little library, which is a knockoff of something called Smooth State, where you go to the server, get the whole page from the different URL, and then strip out the stuff that you actually, the content pane only, which makes it not technically faster as far as the transport goes, but feel faster because, again, you're only replacing with stuff. And then you can do some cute page transitions and stuff where you swipe in content, bring it up, down, slide up, and stuff. I've got a great demo for that, but I'm worried about the speed of this interface right now. So what we really want to talk about, well, how do we wire in these components? And so this is the app, because you remember, in an ideal world or using Chrome, you don't need anything to run these web components. But there's, unfortunately, or fortunately, there's other browsers, competition, that you need to create, need to load these polyfills. You need to detect what the browser is or what capabilities it has. So what we do in the head tag, and this is our a standard head tag that has all the visual things. We load jQuery as slim version, and we load it asynchronously, meaning we can proceed to do this, which is we have a little JavaScript called setup, which does these tests. Does the browser support promises? IE does not. We load promises first. Does the browser support other stuff? And then we add the stuff necessary so that we can run these web components depending on browser capability. So, oh, you saw that I commented out a couple of lines here, but I can override the default behaviors at the end of the setup.js. We load something, a JS that we keep in a folder called JS main.js, which is our web app, custom web app specific instructions for loading. So it goes in here, and then it loads stuff that we know we're going to need for our particular web app. In this case, we need dot, that's a mustache style of data binding library that we want. We load standard web components support, some utilities, the TW stuff that you saw earlier. If we want to use another component library and we need support for that, Riot is a component library, beautiful, very cleanly written. We could load it here. If we needed Vue libraries, we could load them here. By the time we're through this, Topsy Turbo, this is the thing with the page transitions that I was talking about. A couple other base classes for communication and stuff that we usually use. And then once that's done, we trigger so-called the equivalent of a page loaded event, which means after this and the HTML has been loaded, basically the complete DOM is present in the browser and we can do our usual stuff. Same thing as page loaded. With the difference is that our page loaded, which gets triggered by this little tuple library here, we say, well, now let's load our components. Let's late load them. So at this point, the page is visible. We have the page with the menu at the top is visible. The JavaScript, this gets triggered here, load comps. We have a little helper, which is our replacement for this HTML import stuff that you saw earlier. Here we're loading from a shared server, our shared common component called gaugel.html. And then we go have another function which does potentially more stuff that we want to do in the page. Tell the guy, hi, welcome, you're new here. More stuff here. The DOM is the page has been completely built. As part of this happening, the DOM received the loading of the component abbreviation. The whole page will have upgraded its tag, gaugel in this particular case, and will display a beautiful gauge with a default value. This would be also the place where we wire an interaction between different components. But what's the advantage of late loading versus early loading? Well, speed. It does take a browser a little while if you're to load components, upgrade all that stuff, no matter which browser. If you use these web the standard web components, it can be pretty fast. If you use Polymer, you lose maybe half a second. Now, some people say, well, let's load the whole everything first before we render anything. Or let's show them a twirly waiting spinner for so long until we show them anything. I personally don't believe in that. I want the user to see something and then something happening. And if it's a spinner on the individual component or just a gray square that upgrades to the beautiful version or a picture of it or something. That's why we choose late loading wherever possible. If you go to the Polymer website that they have for a Polymer conference, the page shows up, but then it takes 2 seconds until the menu shows up with what you can do, speakers this, and so on and so on and so on. Personally, not my thing. I want the menu to be first. I want to see something, and then late load. But you can choose. You don't have to do it that way. You can preload things before you render, of course. Here I'm showing you how we late load. More thing about wiring. Okay, maybe any questions so far? Because I don't know if the speed I'm going at. No, good. We're good.
Yeah, I do have.
Go ahead.
When you say the shadow
Mm-hmm.
DOM and you were talking about the bleed of the CSS,
Yep.
is that when it's rendered to the view that you have the bleeding, or is this before it gets rendered to the view that you're trying to encapsulate it so that it's hidden?
Well, eventually, if we didn't have shadow DOM, then everything that you show would become part of the DOM. So what that means is if you have a style that's written somewhere else for something else, but your component happens to have the same name, it would be it would be conflicting. It would be going into the component. Or if your component had a style, it would be going outside. That's what you want to avoid.
So you're saying ignore whatever
Yeah.
is in here. So if you had a global p tag that is red, then
Right.
your
Exactly. That's the purpose of the shadow DOM. So loosely coupled business logic and intercomponent communication. That's part of the wiring. So because then, so now we got a basic component that renders a value, and we have a component that renders a list or a dropdown or something. How do we make that work with actual data? So, come on. So again, more Pug. Block in Pug means it's a piece because Pug allows you to use templates where you have an overall frame template for everything, and then you say, well, this whole fill it to me with this. And in this case, that's the fill the content wrapper, the main page, not the header, but the main part of the page. Fill it with this. Well, because this is actually page HTML, right? Without header and stuff. So MUI is a CSS framework, MUI CSS that we use, fluid container, List as component. Here you see that you have a list element. That's a custom component. Tag with an attribute, my custom list title. If you write your component properly, then of course you can pass in the stuff into the component, which gives it the nice title that you want it to have, for example. So browser, as the browser renders here, it doesn't know anything to do with that, but once it's been told that the whole page has been loaded, it goes here. And here now we have the case where we can't just render the component. Actually, what we need to do, we need to get a list of these sites or list of something. We need to get it asynchronously from somewhere. So make an AJAX call to some server somewhere. So what we do is we encapsulate this business logic in a separate JavaScript, in this case called list business. So we load that list business, and when it's been loaded, load comps, we load the comp. You saw that before. And then once we're done, we're doing the heavy lifting, which is our list business has a method called list. And buried inside that list business, well, we pass it the name of that component. So the heavy lifting happens inside here, where it says, well, go to the server, get me the data, and then render it, pass it on to the list element for rendering. So this is all that the page has. It's very clear of what it does, what it's supposed to do, and all the ugly stuff. As far as going to the server, the business logic is encapsulated in our list business, and the rendering ugly stuff is encapsulated in our component, which is great. Now, why don't we put the business logic inside the component? Very, very important. Well, one premise is that in 2 years, this is not going to be the greatest thing as in sliced bread anymore. Maybe we decide to use Polymer then. Maybe we decide to use Polymer now, and in 2 years from now, there's something that's way better than Polymer. So we don't want to have to rewrite our whole business logic. We think a component is great for making rendering sexier, beautiful, encapsulated. But our business logic, going to the server, querying, finding out what to render, should be outside, can be outside. It's nothing to do, it's not supposed to be in a component. And that way is like, well, if you have newer, sexier implementation of a gauge, you wrap, nothing here changes, except maybe the URL for the component, for the component in this case, the list component. Next thing that we stay away is framework-specific component communication mechanisms. So, if you remember the dashboard had in the middle, it had a list of stuff, and when I clicked on it, it sent the values over to the others. Now, I use Polymer, I use any framework, they'll have their way of how do I communicate this. React is very specific about it, even though you've got 5 different ways of implementations of pushing things around here with the whole overall state and stuff. We say stay away from anything that's part of a particular component framework, because then you're stuck with that framework forever. So what we do is we create our own bus of functional reactive programming streams. I'd like to dive into that because I could speak of that for hours, but I'm not going to. But the point is, all you have to do in the page itself is, because my list business is built on a base class, yes, we do use inheritance there, that has these bus features, I can just use the list business that I use anyway for querying. I can also use it as the communications bus, and it's functions for that. And with this one line to the list business, I add I basically I pass the list business to the component. I pass the bus to the component, so then the component knows who to talk to. And we're in 8:43. We've done 40 minutes, 45 minutes. If you want to see how that bus works, come to me after. How's that? It's very exciting. If not, it's also in the tutorials. Actually, but not very detailed. But the point is, we really try to stay away from framework-specific component communication. And I wish I could go more into detail. So next, we're getting into the perspectives. Evaluate Polymer. Now, Polymer is a framework created by Google that does some of the things that we need out of the box. Now, I've showed you stuff doing it the standard way. If you one thing, for example, that Polymer has is data binding. Now, the standard does not have data binding. Here's an example of a standard way of implementing data binding. This is, for example, my component, I want to render a list. So from dynamic data. So what I would do is, in the list function, oh, you remember the list function that I called? Right? That's an example of a list function where I'm saying, hey, in my shadow DOM, let me get the myList div, and then figure out how to turn that one div into an actual list of things. And now I've got 1,000 different ways of doing that. There are so many mustache style libraries out here. We just pick one, JavaScript2.com. It's called .js. They claim it's very fast. There have been comparisons made. It's very fast. And there's multiple ways of writing a template. You can just string it down here, but here you can actually embed it in your HTML in a script tag, and have the raw HTML, and then with the mustaches around here saying iterate through my list that I got, the values, the list that I got from the server. There's one step missing here, right? I didn't show you that because in the page there was the call to the list passing the name of this component here. But I didn't show you how the list business got the data from the server and actually called this function here. I just wanted to make sure that it's not, directly connected. It's not the identical function being called here. There's one extra step. But point being here, I'm using the template of my choice to turn that template, pass in the data as an array of values, and that will make it iterate over the stuff. And then I write the output, plain string, into the myList div up here, and I'm done. All that to render a list. Now, the list could be more complicated because it has links and stuff, and then it would pass parameters, on clicks, all that good stuff. That's how I do it when I'm using standard web components without Polymer. Polymer would make this a little cleaner. But before, what's confusing is that we use the word template here, or I'm using the word template here. This template has nothing to do with this template. It's just, someone else used the word template before, they did it before, and then whatever. Now, Polymer has a unique solution for that. They also call it a template. There's a big template up here, and then there's the little template down here of type DOM repeat, which is the repeater. And then you iterate through it that way. And when their definition of the component, which in Polymer 1 is expressed like that, when you pass in values, then with this, they will automatically mash it together, push it in there, and while rendering. So that's cleaner. That's very nice. That's more maintainable. But it's also a little slower. I said, depending on half a second, give or take, when you use Polymer for stuff to come up. That may or may not be an issue for you. I like my stuff to come up real fast. Polymer also actually has elements, iron elements, paper elements, material design, gold elements for form e-commerce, make sure that the credit card is actually a credit card number, stuff like that, components, animation that is deprecated, platinum, app-like features, push notification, caching Bluetooth. Some of them are still in progress or being migrated from version 1 to version 2. I didn't show you Polymer version 2 because it still has issues with Internet Explorer. So we tried it out, it didn't work yet, so we're not using it yet. Essentially, it makes this custom Polymer tag look a little, it uses more, instead of this, it uses class, which is nicer until you know that it's really cheating to use class in JavaScript, right? So Polymer has a lot of nice things, and you should check it out. You should evaluate it. We can actually help you evaluate it too. You can find this sample project that I just showed you on webcomponents.org. There's tons of components that most of them are standard components. Some of them are Polymer components. Or for some of them you need Polymer, for others you don't. I wouldn't be complete unless I talked about server-side rendering. Now, not every application you want to wait an extra half second or a second for stuff to come up. So you might want to do things on the server side. We used to do that in the very good old times where the whole page was delivered as one. Now people are starting to think, well, maybe we should do that again. And remember the list business that we used? We actually write it as a JavaScript that can be used both on the server as a universal JavaScript, but you use both on the server and the client. Identical, or almost identical in this case. Instead of list, we're calling a server-side rendering list. And so I'm passing this. I'm getting the template. So here I'm getting the raw file. Turn it into a jQuery server-side version of jQuery kind of document, so that this SSR list basically works identically as my client-side stuff. I pass the .template to it too, and in that implementation, I mash the two together. I match the data for the list that I got with the template, show it all in one HTML, and then bring it back here as the HTML, and I send it back as a response to the browser. So this is a JavaScript that uses notably the Cheerio library, which is core jQuery for the server. And I'm using the same list business that I've used for the other stuff. So this is universal business logic. So you can write it for the client side first. If it's too damn slow, you can use it on the server side using this construct. And you can decide that on a case-by-case basis. Haven't done it with any others than the Node, so I can't answer that.
How would this compare to something like TotalJS?
A package called Server Components, which is an effort to implement the same APIs that we talked about earlier, the elements. So you can create an element on the server side that looks and quacks like an element in the browser. That may be a way to actually do components, because what I just showed you before was not technically a component. It was the business logic running on the server side. To actually render a full Polymer component on the server side is a very tricky thing. Nightmare may be a solution. Nightmare as a library, as a browser, emulator, kind of you virtual visit a page, and then you get the stuff back and turn it back. At the Polymer conference in Copenhagen tomorrow, some guy from Google is going to tell everyone how that's going to work. I don't have the answer yet because it's not tomorrow. Hopefully we'll have more answers after tomorrow to server-side rendering of complex components. But that brings me to the summary. Trying to remember the goal of creating maintainable future-safe apps fast. So you have a right to decide the added value of a component, whether you actually want to take code and turn it into a component case by case. You know, you're not being forced to create a button component. A button is a button. A button is not a component. Like, I would think of a component as something complex, but good for reuse, like a list of news, a list of events, a contact us form that you use on 3 different websites, but they basically look the same. To me, that would be a coarse-grained but component that's worth turning into component. But not everything is worth turning into component. The whole app shell, to me, is not worth turning into a component. Polymer does that. I don't want to do that. You have a choice as a developer. Does it make you more productive and the code more maintainable? If yes, yes. I like an app shell to be plain HTML. Avoid lock-in by component framework-specific navigation mechanisms. Routers, custom routers that are their own frameworks. Once you have a mechanism for routing, then you're pretty much stuck with it, I would say. Don't do it. We have a URL, browser history. That's a great router. It's been around for a long time, and it works. You can bookmark it. Keep business logic outside of components. We covered that. Very important. Avoid framework-specific component communication. Sorry, we couldn't get into more detail on this. Apply best practices. There's a lot of other best practices and how to stuff. Try to not do compile, down compile, package, webpack this, unpack that, decompile, and so on, if you can avoid it. I try to write the code in the project so that it's immediately renderable without having to be packaged for deployment. Basically, my project folder, my code folder should look like what gets deployed. That's one of them, but there's many others. Some of them, again, are in here, available for free online. So, unfortunately, this is the last copy of my book. Otherwise, I would have offered some here. But I'm ordering new ones. If you want one, shoot me an email. Where is this stuff here? Come on. Come on, why are these windows here? All right. Okay, so we're offering still a couple of places available. Polymer Best Practices Bootcamp. Actually, next week already. Tail end of next week, Web App Front-End Best Practices. You can go here to register, look, check out what the agenda is. You can go here to check out what that is. That's actually 3 days, more intense, very, very detailed into what we call best practices. We're considering a Polymer conference. November is maybe a little enthusiastic, but if you're interested, to get a free pass by offering half of your time and the rest of the time for lessons, workshops, talks about Polymer, send an email on to me at hi@appthings.io. And if you think your company could benefit from, from any of this, maybe an evaluation of standard web components, one-day in-house workshop, contact me, hi@appthings.io. If your company happens to be East Coast, we have a representation on the East Coast as well to do that stuff. So Any questions? Hi, appthings.io. There's a phone number as well. There's a website, appthings.io. If you shoot me an email to this address, I will send you the link of the published version of these slides, plus the links to the GitHub and so on, where the sample projects, there's 8 of them or something that are part of the tutorials. Send all that to you. That is actually the last page.